Hello everyone, welcome back to QuantX Research. I'm Utkarsh Dubey and today we'll be diving into the ordinary least square method. Yes, my dear friends, OLS method is one of the most popular method in the econometrics. If we talk about the basics of OLS, then it's a method used for estimating the parameters in a linear regression model. It minimizes the sum of the squared differences between the observed and predicted values, which helps in finding the best fitting line through a set of data points in a scatter plot. So now let's understand it with the actual scatter plot. For example, we have this scatter plot where these are the data sets and this is our SRF. Okay, these are sample regression function. So as we are seeing here, our data points are not exactly at the SRF. Our expected regression function, right? So it's a reality and it's our expectation. So whatever the difference between the actual data points and are the SRF is our U cap. Also sometimes we use epsilon right here. So our job is to reduce the squared value of a U cap or U2 cap or UN cap. So as much as reduced value of our squared form would be, our OLS estimate would be as much as accurate. If we try to make the OLS model in a mathematical form, then we would get y equal to beta 0 plus beta 1x plus epsilon. We can also use another symbols as well, but here if we are taking y equal to beta 0 plus beta 1 x plus epsilon, then here y is representing the dependent variable, x is representing the independent variable, and beta 0 is representing the intercept, right? So this one is representing, right, it's a beta 0, okay, and beta 1 is representing the slope. So the slope of our SRF is represented by the beta 1, right? So if we are taking the example of a consumption function, so our marginal propensity to consume would be the slope of our economic model. There can be lots of example like this. And if we talk about the assumptions of our OLS model, then there are mostly 5 to 6 assumptions. For example, linearity, right? Independence of observations, homoscedasticity, normality, and no multicollinearity. These are the in-depth topics which we would discuss further, but we can just learn the points for this point of time. Now we will take the example of students study hours and how much marks they are getting using the SPSS software. So let's get started with, right? This is the interface of SPSS software where already we have added the data. So for example, we want to take regression analysis using this software. Then we can go right here, and here we can open our file as I have already opened. So we would go in the linear regression, and here we want to estimate how much marks are depending. For example, maths score is depending on the hours of study, right? So hours of study is a independent variable, and math marks is dependent variable, because how much we will study will affect our math score, right? So I will just simply click here, and yes, magic started. Here is the output, right? All the summary, ANOVA test, all the things are right here, okay? For example, here we have sum of squares 152.100 or 100, residual is 443.1, 0.00 and total is 195.00. Okay, our DF is 1, 3 and 4. Mean square is given, DF statistics is given, and if you talk about R square, right, because R square is a very important in the OLS because it represents the goodness of the fit. For example, here we can understand the R squared value indicates how well the model explains the variability of the dependent variable. R squared value indicates the proportion of the variance in the dependent variable explained by the independent variable. So R squared value is very much important. So as we have seen here, how easily we can estimate our model using the statistical software. In our further discussion, we will deeply understand each and every concepts like all the assumptions and how we will relax the assumption and what will happen after relaxing the assumption. Thank you so much, guys. Maybe there may be a few problems, so please do write all your concerns in a comment section. Thank you so much. It's just beginning. I need your help, so please do subscribe and hit the like button. Jai Hind.